So this is the 16th session on rigid body kinematics. So this is in continuation of the 15th session. Okay. So in this I'll take up the problems on rolling motion. Okay. Theory of rolling motion has been fully discussed in great detail in the 15th session of on rigid body kinematics, that is in the previous video. So in case you don't know the theory of this, then you first refer to 15th video, then you come to this 16th video. Alright. So in this I'll take up examples on rolling motion. Fine. So the question is this. A circular drum undergoes pure rolling over a fixed horizontal surface. Center C of the drum moves ahead at a speed v and drum rotates at an angular speed omega. With respect to ground, as shown. Okay. So I'll write down the question again after that. First I'm drawing the diagram. Fine. The diagram is this. This is the side view of the drum. This is a fixed horizontal surface. This is the center C of the drum. Radius of drum is equal to R. R is the drum radius. Center C moves ahead at a constant speed, at a speed V. Drum undergoes pure rolling without slip over the ground surface. Now it's undergoing pure rolling. It's definitely pure rolling, meaning it rolls. Therefore, it should rotate with respect to ground. A sense of its rotation can be clockwise and anti-clockwise both. Now in this case, it is rolling without slip. So rolling without slip and center moving rightward, sense of rotation should be clockwise. It cannot be anti-clockwise. Because if omega is anti-clockwise, then this point will not be at rest. Then it is rolling with slip. So for rolling without slip, if C is moving rightward, omega should be clockwise. If C moves leftward, omega should be anti-clockwise. Then only pure rolling is possible over a fixed surface. Fine, alright. So this is the condition. Now, at this given instant, P1 is the material point of drum in contact with the ground. P2 is the highest material point of the drum at the highest location. P3 is the point on the surface of the drum at the same horizontal level as the center C of the drum. And P4 is the point here. We join CP4. This angle is theta. Okay, fine. Now, we have been, first we have to find several things we have to calculate. We have to calculate several things. Several things have to be calculated. Fine. Now, what are those several things that I am mentioning? So, first of all, what we have to do, we have to find the relation between V, omega and R. Find the relation between V, omega and R. Find the relation between V, omega and R. That we have to tell. What is the relation between V, omega and R? That we have to specify. Okay. So now how do we do that? How to find the relation between V, omega and R? That is the question. So I'll draw the diagram here again for the sake of clarity. Okay. See, this is the center C of the drum. This is the point P1 of the drum in contact with the ground. This is the ground surface. With respect to ground is fixed. See, the ground frame is the frame under observation. We observe the drum from ground frame. Okay. So with respect to ground frame, the ground frame is at rest. This point of ground G1 is at rest. The drum is undergoing pure rolling over the ground surface. But I discussed just now in the previous video on 15th session, I told when one body rolls over another pure rolling, then the velocities of 2 points of two bodies in contact are always equal. So G1 is at rest with respect to ground. So with respect to ground, P1 should also be at rest. So this is also at rest. Okay. Now what I do? We have to find the relation between V omega and R. We apply SRC procedure for velocity between C and P1. Okay. So SP we take as point C. Other point we take as P1. Now we draw the line joining C and SP and OP. That is this line. Now what action we take? We give the velocity of selected point to other point. Velocity of selected point C is V rightward. So we give velocity V to what? P1 rightward, V. Okay. Now rotation term we combine. For that we write down the sentence. P1 moves in a clockwise circle with C as center, radius R. So if P1 is to move in a circle with center C and radius R, we give a speed omega R to P in leftward direction. Then only it is going to be a clockwise circular motion. The velocity of P1 now is vector sum of these two. But P1 is at rest. So vector sum of these two should be at 0. So V minus omega R should be 0. So V should be equal to omega R. So this is the condition for pure rolling. This is the relation between V omega and R for pure rolling of a body over a fixed surface. Okay. Actually, in this I have taken the surface to be horizontal. It can be any orientation. It is not necessary that surface should be plane. It can be curved also. So that this relation will be instantaneously valid. Okay. So one thing has been proved. Fine. Now I have this one. Now next condition is find the velocity of P2, P3, P4 with respect to V. Find velocity of P2, velocity of P3 and velocity of P4 in terms of V. Okay, that we have to find in terms of V, and wherever in VP4 we can theta also should come, but in VP2, VP3 only in terms of V it should be. Okay, or it should be only in terms of V. Fine. Now I will have this. Fine. So, to find VP2, VP3, VP4, first we find VP2. So, we apply SRC between C and P2, okay. So, SP arrow C, OP arrow P2, okay. Then you draw the line joining C and P2. So, I draw it here itself, okay. I draw the complete drum itself. This is C, this is P2, okay. I draw the line joining C and P2. Fine. Now I give the velocity of selected point to other point. Velocity of C is V rightward. So I give V to P2 rightward direction. Okay. Fine. Then I write down the rotation term. Rotation of the drum is omega clockwise. So P2 moves in a clockwise circle with C as center and radius R. So P2 I give a speed of how much? Omega R. Okay. And now we have to combine. The velocity of P2 is the vector sum of V and omega R. As we discussed just now, omega R is just equal to V. So resultant velocity of P2 is a vector sum of these two. From parallelogram law of vector addition, Vp2 becomes V plus omega R. That is V plus V, that is 2V. 2V in rightward direction. First answer we have obtained. Alright. The velocity of P2 is how much? 2V in rightward direction. Fine. Now next is find the velocity Vp3. P3 is here. Now we have to find Vp3 in terms of V. Again, we apply SRC between C and P3. SRC for velocity between C and P3. Okay. We apply SRC velocity between C and what? P3. So, selected point becomes C, other point becomes P3. Okay. Now, what action do we take? We draw the line joining SP and OP, that is CP3. So, I draw the complete drum itself. This is C, okay. This is P3. Now give the velocity of selected point to other point. Velocity of C is V rightward. So P3 also I give V rightward. Now I write down the rotation term. Drum rotates clockwise. So P3 moves in a clockwise circle with center as C and radius R. So this I give R omega, clockwise circular motion. Now R omega is just V, as I discussed there. Net velocity of P3 is the vector sum of these two. V and R omega. Angle between V and R omega is 90 degree. So we from parallelogram law of vector addition, Vp3 becomes V square plus omega R whole square. But R omega is just equal to V. So V square plus V square, that is just equal to V root 2. So this is the answer to the part velocity of P3. Fine, alright. Now I love this one. Third, we have to find Vp4. We have to find Vp4. Again, we use SRC for velocity between C and P4. SRC for velocity. We'll come in the next successive videos. We'll discuss. There is also SRC for acceleration also. SRC between P4 and C. SRC between P4 and what? C. Okay. So SP arrow C, OP arrow P4. SP arrow C, OP arrow P4. Now I draw the line joining C and P4. I draw the drum itself. Okay. This is C. This is P4. Okay. This is the vertical line. This is theta. Alright. Fine. Now what I do? Give the velocity of selected point to other point. Velocity of selected point C is V rightward. So I give V rightward to P4. Alright. Now then what do I next? Circular motion concept. Omega of drum with respect to ground is omega clockwise. So we say P4 moves in a clockwise circle with C as center and radius R. From clockwise circular motion theory, velocity of P4 should be R omega, that is V, tangent to this circle. This right angle by geometry, this angle is also theta. Okay. The third is combination step. Velocity of P4 is the vector sum of V and R omega. Angle between these two vectors is theta. So from parallelogram law of vector addition, V4, that is Vp4, that is just equal to root under V square plus R omega whole square plus 2V into R omega into cos of theta. This becomes root under V square, R omega also V square, 2V square cos theta. Okay. This becomes how much? 2V square 1 plus cos theta. Alright, fine. So this I have in the first column. Okay. Now 1 plus cos theta is 2 cos square theta by 2. So Vp4 is just equal to root under 2V square into 2 cos square theta by 2. On simplifying it, it becomes 2V cos of theta by 2. This is the answer to the velocity of P4. Okay. So this is solved. I discussed the SRC method. Fine. Alright. Now I take some other questions on rolling also. Some other questions also on rolling. Fine. So, now I take another question. A cylindrical drum with center at C and radius R rolls without slip. Rolls without slip over a fixed horizontal surface. And its center C moves rightward at a constant speed V. At a constant speed what? V. Okay. is this diagram bit. Okay. As shown. So this is the see, this is the drum. Okay, this is the center C of the drum. R is the drum radius. Center C moves at a constant speed v towards right. Okay, this is a fixed horizontal surface. Now this undergoes pure rolling here, rolls without slip. So for pure center C is moving rightward, here rolling without slip. So rotation sense should be omega anti-clockwise. Okay. Now at time 0, suppose this situation I have shown. Okay. Now suppose at time 0, t0, the lowest point of the drum coincides with the origin of the coordinate system, and the coordinate system is fixed to ground. So at time 0 the situation is like this. This is the drum. This is the drum at time 0. This is the lowest point of the drum, point P. This is the center C of the drum. R is the drum radius. R is the radius of the drum. P is the lowest point of the drum in contact with the ground at time 0. This is the origin of coordinate system fixed to the ground surface. X-axis is rightward. Y-axis is vertically upward. Okay. Center C is going rightward at a constant speed v. Here it's undergoing pure rolling without slip. For that rolling without slip, omega should be clockwise. Okay. At time 0, point P is in contact with point O. Fine. At time 0, point P is in contact with point O. Point P and point O are in mutual contact at time 0. Okay. And P is the material point of drum in contact with point O at time 0. Okay. Fine. Now I love this one. Now we have to solve several things. Okay. See, it's like this. So first thing is this. Find the angular speed omega of the drum in terms of V and R. Omega in terms of V and R. As just discussed previously, V equal to omega R with pure rolling condition. Is it fine? Alright. So in terms of find omega in terms of V and R, as I just discussed just now in this video itself previously. So from that I discussed that V equal to omega R. So omega is equal to V by R. Now speed V is given to be constant. R is the radius constant. So omega is also what? Constant. So omega is what? Angular speed of drum. What is meant by angular speed? Angle turned through by the drum in 1 second. Now omega is V is constant, so omega is also constant. The second thing is this. Find the time period of one full rotation of the drum. Find the time period T of one full rotation of the drum. Find the time period capital T of one full rotation of the drum. Now how to find T? That is the question. Now omega is the angle turned through in 1 second. In T second, omega is constant. Suppose omega is say 4 radian per second. Suppose, just for the sake of argument. In 1 second, the drum will rotate through 4 radians. In T second, it will rotate through how much? 40 radians. So in one full rotation, it will turn through an angle of how much? 2 pi. But in one full rotation, how much angles will turn through? Omega into capital T. And that is equal to 2 pi, because one full rotation, the disk will rotate through 360 degree, it is 2 pi radians. So time period of one full rotation will be 2 pi by omega. This is also one answer. Okay, fine. Now third is this. Third is, find the magnitude of displacement. Find the magnitude of displacement of point P of the drum with respect to ground in the intervals 0 to t by 2, 0 to t, B 0 to t by 2, C 0 to t by 4, D 0 to t by 3. Okay, in these intervals we have to find the magnitude of displacement of point P of the drum with respect to ground. Fine. So this is a bit, okay. So now each of these cases I take, okay. So part A, third part, part sub A of third part, okay. In 0 to t by 2, we have to find the displacement of the lowest point P of the drum, magnitude in terms of radius. So at time 0, the drum is like this. This is, 0 to t we have to find first, 0 to t, okay. At time 0, point P is here. This enters C. Now let us call this highest point as P0, okay. Now in one full rotation, drum will turn through an angle of how much? 2 pi, and the center moves some distance ahead. So at t barabar capital T, this is the situation. At t barabar capital T, this is the situation. See, again this one time period, the drum will turn through an angle of 2 pi radians. That is this line P0 CP, that will also turn through 2 pi radians, that is 360 degree. So at t barabar capital T, P0 P CP will be like this again. It will appear like this. P0 C and P. So displacement of P is simply this. This is the displacement of point P. Now this displacement is same as the displacement of center, D of C. So displacement of P with respect to ground is same as displacement of center with respect to ground. But center is moving from here to here at a constant speed V in time capital T. So that is equal to speed into time, V into T. Now T is how much? 2 pi by omega. Now V equal to pure rolling condition. From pure rolling condition, V is equal to what? Omega. Omega cancels out. 2 pi r in rightward direction. This is the answer to sub part A of the part 1. Okay. So displacement of point P with respect to ground is simply 2 pi r in rightward direction. Okay. Fine. One answer has been given. Now we have to find the displacement of point P with respect to ground in the time interval 0 to t by 2. In the time interval 0 to t by 2, we have to find the displacement of point P with respect to ground. Okay. This I'll rub it now. So now 0 to t by 2. Again I draw the diagram here. This is the drum at time 0. P0 is the highest point of the drum. C is center. P is here. In time capital T by 2, the drum will turn through 180 degree. Because in one full time period it will turn through 360 degree. So in half time period it will turn through 180 degree. That is pi radians. So T barabar capital T by 2. Diagram will be something like this. Now, as I said just now, in 0 to t by 2, the drum will turn through an angle of 180 degree, that is pi radians. So line P naught CP, that will also turn through an angle of 180 degree. So at t naught t by 2, P naught Cp will be inverted with respect to itself. So at t equal t by 2, P naught will be here, P will be here. At time 0, P was here, t equal t by 2, P is here. So net displacement of point P becomes this much. This is the net displacement of point P in interval 0 to t by 2. Now you can see this dp is this square plus this square. Pythagoras theorem is this square plus this square. Now this is same as dc. This is c here. So center moves from here to here at a constant speed v. So this distance is how much? Vt by 2. So this distance is also how much? Vt by 2. And this is how much? 2r. From Pythagoras theorem, dp becomes how much? This rabbit becomes root under Vt by 2 whole square plus 2r ka whole square. Fine. So this becomes root under, now V becomes how much? R omega. R omega by 2 whole square plus 2r whole square. Omega into t is how much? 2 pi. In part A of the first part of this question. So this becomes how much? R omega t becomes 2 pi by 2 whole square plus 2r ka whole square. Ho gaya. 2 goes away. R cancels out, comes out common. Pi square plus 4 is the answer to part B of the subpart 3 of the question. Okay. This is a little bit fine. Third part is this, part C is this, part C. Displacement of point P in the interval 0 to t by 4. Capital T is the time period of one full rotation. So again draw the diagram in this case. This is the diagram at time 0. This is the horizontal surface. This is the P naught point at highest point, this point P here. This is the center. Now in 0 to t by 4, in t by 4 the drum will have moved some distance ahead, somewhere here. This is at t equal to t by 4. Okay. T equal to t by 4, drum has come here. So now, see, in 0 to capital T, drum turns through an angle of 2 pi. So 0 to t by 4, drum will turn through an angle of how much? 2 pi into by 4. That is 90 degree. So that is this line P naught Cp will turn through clockwise through an angle of 90 degree. So at time t by 4, this line P naught Cp will appear something like this. P naught will come here, center C is here, P is here. The displacement of point P becomes this. This is the displacement of point P with respect to ground in the interval 0 to capital T by 4 from here to here dp. Now dp, to find dp, we drop a normal from here. dp is this square plus this square. Let us call this distance as say x1. So from this, and this distance is radius r. So dp is equal to root under r square plus x1 square. Now we have to find the value of x1. Now how to find the value of x1? See, initial center was here, center has moved here. The center has undergone a displacement of say dc. Now you see from diagram geometry, this equal to this plus this. You can see dc is equal to this distance x1 plus this distance, which is simply r. So that means x1 is equal to dc minus r. Achha, what is dc? dc is the displacement of center of the drum with respect to ground in the interval 0 to t by 4. Now the center is moving at a constant speed v. So in time t by 4 it will move through a distance equal to speed into time. So dc becomes how much? Vt by 4 minus r. Okay. Now what is v? V is equal to r omega. So r omega t by 4 minus r. Omega t is simply 2 pi. So 2 pi r by 4 minus r. That becomes pi r by 2 minus r. Okay. Pi r by 2 minus r, that is dc. And r is how much? X1 is equal to how much? This is x1 is equal to this much, and this if you substitute as x1 here, then we get dp. Fine. So this is a bit now. So net displacement of P with respect to ground will be root under r square plus x1 square. x1 is this pi r by 2 minus r whole square. This becomes r is common. 1 plus pi by 2 minus 1 whole square is the required answer. Okay. In part D, we have to find the magnitude of displacement of point P in the interval 0 to t by 3. Okay. Again, I draw the diagram as I have been doing in part A, B and C. The time 0, the situation is something like this. This is center C. This is point P. This is point P naught. At t equal to t by 3, the drum has moved ahead. Now see, center is here. Now see, in 0 to t by 3, the drum will turn through an angle of how much? 2 pi by 3? 120 degree. So the line P naught C, P naught CP will also turn through an angle of how much? 120 degree. So for line to turn through an angle of 120 degree, it should be something like this. At t barabar t by 3, line P naught CP should be something like this. Initially it was like this, and it turns to like this. So this angle is how much? From vertical this angle is how much? 120 degree. Now displacement of P will be this much. This is the displacement of point P with respect to ground interval 0 to t by 3. Alright. I'll rub this one. So, now dp is again, what do? I drop a normal from here. The dp is this distance, let's call this distance as say x2. And this distance as something we will calculate. So dp is this square plus this square. Let us call this distance as y2 from here to here. Okay. So what do we see? We see that dp is equal to root under x2 square plus y2 square. x2 square plus y2 square. Now how to find x2 is the question. See, center is here and center is here at t by 3. So this distance is dc, displacement of center dc. From this we see this distance plus this equal to this. Now how much is this distance? This is 120, so this is 60 degree. This is also 60 degree, opposite angles. So this distance, let us call this distance as say, some say x naught say. So from this what we see, dc is equal to this plus this. dc is equal to x2 plus x naught. x2 plus x naught is equal to dc. So x2 becomes how much? dc minus x naught. Now center is moving at a constant speed v. So dc is equal to speed into time. v into t by 3. And what is x naught? X naught is this distance. That is this distance. That is simply r sin 60 degree. Minus r root 3 by 2. Now vt is how much? v is equal to r omega. R omega t by 3 minus r root 3 by 2. Omega t becomes 2 pi. 2 pi r by 3 minus r root 3 by 2. This is x2. Now we have to find y2 to find dp. And y2 is what? This distance. This plus this. This is equal to r plus this distance. This distance same as this distance. But in right angle triangle, this is r60, this is r cos 60 degree. So r by 2. So 3r by 2. That is y2. Now substitute y2 and x2 here. So dp will then be known. So dp will be equal to x2 square. x2 is how much? 2 pi r by 3 minus r root 3 by 2. Minus r root 3 by 2 whole square plus 3 by 2 whole square, which is therefore the required answer. Alright. So in the 16th session of rigid body kinematics, I have taken many problems on pure rolling motion. Okay. In coming videos also 2 or 3 videos, I will be taking more problems on this rolling motion. Fine. So you carefully go through this if you understand it, and then take up numerical from any other source. I am sure you will be able to solve most of them without any difficulty. Okay. So you will go through them and that's finished. Alright. So the next video will be more on rolling motion itself. So I close it here. Fine.